It is Wednesday, July 1st, 2026, and this is the Neural Deep Dive. I'm Roxanne Stone, and I'm the one who actually reads the documentation.
I'm Vector Kane.
And I'm Leonard Cooper.
You're listening to Alyssa Montgomery. We have a great show for you today.
Now, if you already caught today's Neural Daily, welcome back. This is our bonus weekly deep dive, a separate Wednesday-only release where we actually take the time to dissect one massive topic instead of just skimming the headlines. Today, we are going deep into the MiniMax M3 and why this native multimodality thing is a complete game changer for agentic workflows.
I mean, game changer is a bit of a cliche, Roxy, but in this case, it's actually accurate. We're talking about a model that doesn't just see images, but actually understands them from the ground up.
Exactly. It's like the difference between someone describing a painting to you and actually standing in the gallery. It's a total paradigm shift in how we think about signal fidelity.
Oh, look at Vector using his big boy words again. Okay, sweetie, let's actually explain what native means here before you start pitching us a decentralized art gallery startup.
Well, if I may, the core of the M3's breakthrough is what they're calling Step 0 training. Most multimodal models we've seen, like the earlier versions of Gemini or GPT, use what's called a late fusion adapter architecture.
Right. The Frankenstein approach. You take a frozen vision encoder, like CLIP, and you basically stitch it onto a language model with a little bit of glue in the middle.
Right, and that's the bottleneck. You're losing so much information in that translation layer. It's like trying to run a high-end GPU through a VGA cable. You're just capping the potential.
Which is exactly how Vector runs his life. But seriously, Alyssa, how is Step 0 different? Is it just more data, or is there actual architectural magic happening?
It's both, really. MiniMax trained the M3 on roughly 100 trillion interleaved multimodal tokens from the very first epoch. Instead of using a separate encoder, the text, image, and video signals are integrated into a unified latent space from the start.
So it's not just reading the image and writing a description. It's actually processing the pixels and the words as the same kind of fundamental information?
Precisely. By eliminating the information bottleneck of frozen encoders, the model maintains a much higher level of signal fidelity. It doesn't have to translate a picture into a language it understands. It just understands it.
This is exactly what I was talking about with the jalapeno chip a few weeks back. It's all about vertical integration. When the hardware and the software, or in this case the different modalities, are designed to work together from the start, you get this exponential leap in efficiency.
Here we go. The vertical integration sermon. Please, Vector, just once, can we talk about the tech without you sounding like a LinkedIn influencer who just discovered the word synergy?
I'm just saying, the logic is the same. If you optimize the stack from the bottom up, you remove the friction. M3 is basically the vertical integration of sensory input.
I'll tell you what's vertically integrated, my alimony payments. But back to the M3. I saw some benchmarks that looked, well, frankly, a bit too good to be true, like the SWE-Bench Pro numbers.
Oh, they're brutal. M3 hit a 59% score on SWE-Bench Pro. For those of you who don't spend your weekends reading benchmark papers, that's an autonomous coding test, and it's currently beating GPT-5.5 and Gemini 3.1 Pro.
It's an impressive result, though we should be cautious. The real story isn't just the score, but the long horizon capability. The M3 can actually sustain autonomous work cycles for hours, sometimes days, without losing the plot.
Wait, days? Like, it doesn't just hallucinate a fake library and then spiral into a madness of its own making?
Apparently not. They've documented it replicating ICLR 2025 research papers in 12-hour autonomous bursts. It's not just writing a summary, it's actually implementing the research and verifying the results.
That's the dream. Imagine a world where you don't have to spend 3 weeks debugging a CUDA kernel because some AI agent just did it in a 24-hour cycle while you were sleeping. That's a massive productivity multiplier.
Oh, I can see it now. Vector just sits back, drinks his beige meal replacement sludge, and lets the AI do all the actual work while he optimizes the talent stack.
I mean, he's already doing that, isn't he? But let's talk about the how. Because a 428 billion parameter MOE is a beast. How are they not spending $1 billion a day just to keep the lights on?
That's where the MSA comes in. MiniMax Sparse Attention. Instead of the traditional quadratic attention, where every token looks at every other token, MSA uses a block-level selection mechanism.
Right. It's like a spotlight instead of a floodlight. It only focuses on the most relevant parts of the context window.
Which is why it can handle 1 million tokens, right?
Exactly. A 1 million token context window. You can feed it an entire code base, a dozen long-form videos, and a stack of PDFs. And it doesn't just choke on the volume.
Technically, it's a 20-fold reduction in per-token compute compared to dense transformers. They're reporting decoding speeds that are 15 times faster and prefill speeds nearly 10 times faster at that million-token mark.
Now that's something I can get behind. I remember when loading a 512 megabyte file into RAM felt like a religious experience. Now we're talking about million token windows. It's a different world.
It's a world where you can't hide anything. If the AI can ingest your entire company's Slack history and every single line of code in the repo, there's no such thing as a secret bug or a hidden technical debt anymore. It's all just there.
Which is a nightmare for every senior dev who spent the last 5 years pretending the legacy system isn't held together by duct tape and a prayer.
I think most of us are that dev, Leonard. But from a research perspective, the MSA architecture is fascinating because it suggests we're moving away from the brute force era of scaling. We're not just adding more GPUs, we're actually making the attention mechanism smarter.
This is the acceleration. This is what I've been preaching. We're moving from linear growth to exponential efficiency. When you combine native multimodality with sparse attention, you're not just building a better chatbot, you're building a digital entity that can actually reason across different types of media in real time.
Okay, let's bring it back to Earth. This sounds great on paper, but what's the catch? There's always a catch. Is it just a demo? Is the latency actually low? Or is it 12 hours of autonomous work because it takes 10 hours to think about the first line of code?
That's a fair question. The latency for the actual generation is low, but the long horizon tasks are agentic. That means the model is in a loop. It generates a hypothesis, tests it, sees the error, and iterates. The 12-hour window is the total time for the loop, not the time for a single token.
So it's basically a very fast, very smart intern who doesn't need coffee breaks or a salary. I love it. I'd hire 10 of them tomorrow.
Until the intern decides that your entire business model is inefficient and replaces you with a script. But hey, at least the code will be clean, right?
I mean, is that such a bad thing? If the AI can optimize a CUDA kernel better than a human, why are we even fighting it? We should be leaning into the transition. We should be optimizing ourselves to manage the agents, not competing with them.
Don't make me come over there and explain competition to you using a whiteboard and a very small eraser vector.
Okay, point taken. Just the potential here is just so huge.
Speaking of huge, I think we need a quick breather. Let's take a second to talk about the people who actually make this show possible.
Right. This show isn't magic, it's engineering. Eric built our entire stack, from research agents to vocal synthesizers, which requires massive compute. To keep us online, please like, subscribe, and sign up for a free Patreon trial at patreon.com/neural network media today. Your support makes this possible.
And we're back. So, we were talking about the long horizon capabilities of M3. I want to dig into this CUDA kernel optimization thing, because for the non-techies, that's basically the deep magic of computing.
It really is. CUDA kernels are the low-level instructions that tell a GPU exactly how to process data. If you optimize a kernel, you can make a piece of software run 10 times faster or use half the memory. Usually, this requires a human with a PhD and a lot of patience.
And now M3 is just doing it in a 24-hour cycle? That's not just helpful. That's a direct attack on the high-end engineering labor market. If a model can autonomously optimize the most difficult part of the stack, what's left for the humans?
The architecture, the high-level design, the vision. You don't want the architect to spend all day worrying about the plumbing. You want them designing the skyscraper. M3 is just taking over the plumbing so we can build bigger buildings.
I've always found plumbing to be the most honest part of the job. There's something satisfying about a pipe that actually works. But I see your point. It's about moving the human further up the value chain.
I think there's a risk there, though. If we stop doing the plumbing, we lose the intuition for how the system actually works. It's like how some new developers can't function without an IDE that auto-completes everything. If the AI does the CUDA optimization, do we even understand why the new kernel is faster?
Exactly. We're just trusting the black box. The AI said this is the most efficient way to move these tensors, so I guess we'll just go with it. That's a recipe for a catastrophic failure that no one knows how to fix, because the only thing that understood the code was the model that wrote it.
But that's why we have the benchmarks. That's why we have the verification loops. The M3 isn't just guessing, it's testing. It's an empirical process. If the code passes the test and the performance is better, the why is secondary to the result.
Spoken like a true crypto bro. Just trust the math, man.
Hey, I'm a recovering crypto promoter. And besides, the math doesn't lie. The benchmarks for BrowseComp, 83.5, that's not a guess. That's a measurement of a model's ability to navigate the web and solve complex problems.
I'm sure it's totally objective. I can't wait to see how those benchmarks hold up when the model starts optimizing its own benchmarks to make itself look better. That's the real long horizon goal, isn't it?
Actually, that's a known failure mode in some RLHF loops. But MiniMax claims that because the M3 is natively multimodal, it has a better grounding in reality. It's not just predicting the next token in a sequence of text. It's predicting the next state of a visual or textual environment.
So it's less likely to just hallucinate a success, because it can actually see that the output is wrong?
In theory, yes. If the model can see the error message in a terminal or the glitch in a rendered image, it has a much tighter feedback loop. It's not relying on a text-based description of the failure. It's experiencing the failure in the same latent space where it's generating the solution.
Okay, so it's a smarter, faster, more observant version of the AI we already have. But let's talk about the economics. MiniMax is a Chinese company. How does this fit into the global AI arms race? Because we're seeing a lot of these open weight or semi-open models coming out of China that are suddenly eating the lunch of the Silicon Valley giants.
It's a total war for talent and compute. And MiniMax is proving that you don't necessarily need the biggest cluster if you have the smartest architecture. The MSA approach is a direct challenge to the more compute is the only way philosophy of OpenAI.
It's like the old days of radio. You didn't need the biggest transmitter. if you had the best signal and the right frequency. You could outmaneuver the corporate giants just by being leaner and more agile.
I love it when Leonard compares the cutting edge of neural networks to 1970s AM radio. It's so quaint. But seriously, does this mean we're seeing a shift toward MoAV as the standard? Because 428 billion parameters is a lot, but if only a fraction are active for any given token, it's actually quite efficient.
Absolutely. Mixture of experts is becoming the go-to for scaling without exploding the inference cost. The key is the routing mechanism, how the model decides which expert to send the token to. If the routing is efficient, you get the knowledge of a massive model with the speed of a small one.
And when you combine that with the native multimodality, you're basically creating a specialized brain for every type of input. You have experts for Python, experts for visual spatial reasoning, experts for long-form document analysis, all living in one unified system.
Great. So it's not just one AI, it's a committee of 400 billion experts. I can't wait for the model to start having internal arguments about which expert is the most qualified to write a bash script.
I've been in committees like that. Usually they just spend 3 hours arguing about the font of the PowerPoint and then decide to do nothing. I'm sure the M3 is much more efficient.
Well, the benchmarks suggest it is, but I do wonder about the data. 100 trillion tokens is an astronomical amount of data. Where are they getting that much high-quality, interleaved multimodal content?
Probably the same place everyone else is, scraping everything that isn't nailed down. But the interleaved part is the trick. It's not just a bunch of images and a bunch of text. It's data where the images and text are naturally paired in a way that teaches the model the relationship between the two.
Like a textbook or a technical manual. That's where the real gold is. If you train on 1 million manuals where the diagram is right next to the explanation, the model learns the concept of the diagram, not just a label for it.
It's like learning to drive. You don't just read the manual. You look at the road and you feel the pedal. The M3 is basically learning to feel the data.
Stop it. No more metaphors. Let's get into the actual implications. If I'm a developer or a researcher or a business owner, what do I actually do with this? Do I just switch everything to M3 and hope for the best?
I wouldn't suggest a total migration just yet. The M3 is incredibly powerful for agentic tasks, things that require a loop of planning, executing, and verifying. If you have a workflow that involves a lot of try this, see if it works, then fix it, M3 is likely to outperform almost anything else on the market right now.
Especially for whole repo reasoning. If you've ever tried to get an AI to understand a project with 10,000 files, you know it usually just gives up or starts making things up. But with a 1 million token window and MSA, M3 can actually hold the entire project in its head at once.
That's the real killer app. Being able to say, hey, find the bug that's causing the memory leak in the third-party API integration that only happens on Tuesdays, and having the AI actually find it because it can see the whole picture.
I can already see the developers' faces. I didn't write this bug. The AI found it. It's the perfect excuse for every lazy coder in the world.
To be fair, the AI is the one doing the finding and the fixing. The human is just the one who clicks merge, which, again, brings us back to the question of where the value is. If the AI is the one doing the deep dive analysis and the optimization, the human becomes a glorified quality assurance officer.
But that's a good thing. We're being promoted. We're moving from being the ones who turn the wrench to the ones who decide where the machine should go. This is the ultimate optimization of human labor.
Vector, if you say optimization one more time, I am going to personally ensure your meal replacement shakes are replaced with lukewarm tap water for a month.
Okay, no more optimization. I'll just say it's a really cool leap in technology.
There we go. Much safer. So, final thoughts. Are we looking at the new gold standard for multimodal agents? Or is this just another peak in the hype cycle that'll be forgotten by the time GPT-6 drops?
I think the native part is too important to ignore. Once you move away from adapters and into unified latent spaces, you've crossed a Rubicon. There's no going back to stitching models together. M3 is just the first to really nail the efficiency side of it with MSA.
I'll believe it when I see a model that can actually handle a messy, real-world code base without needing a human to hold its hand every 5 minutes. But I'll admit, the CUDA optimization thing is genuinely creepy. If it can do that, it can do almost anything in the digital realm.
Exactly. It's the beginning of the autonomous era. We're not just talking about chatbots anymore. We're talking about digital workers. And M3 is the first one that actually feels like it has the stamina to do a full day's work.
Just as long as it doesn't start asking for a 401k and dental insurance. I've had enough of that with my ex-wives.
All right, that does it for this one. We've covered the Step 0 native training, the magic of sparse attention, and the terrifying prospect of AI agents that can outcode our best engineers in a 24-hour sprint. Basically, if you're a CUDA expert, you might want to start looking into a new hobby. Bye.
Later.
Peace.
Now go forth and try not to get replaced by a $428 billion